All right, lesson 2.2, rates, ratios, proportions. We're going to mix some percents in here. We're kind of got a lot of different applications for today's lesson. So first of all, a ratio. All a ratio is a comparison of two numbers, all right, by division. So you could think of it as a fraction. So a ratio might be something like 2/3. Sometimes you'll see it written as 2 to 3, either with the colon like that, or they may even just write out 2 to 3. But it's a comparison of two numbers with division. A proportion are two ratios that are set equal to each other. So it's a ratio on the left, a ratio on the right, and you may have something like, x is to 4 as, 8 is to 20, let's say. And then you can solve this by using cross products. So you could cross multiply and get 20x equals 32, and divide both sides by 20, and reduce that down, and 4 goes into both those numbers. Looks like 8/5 maybe. And there you go. So you can always solve a proportion by doing cross products, cross multiplying. A rate, so we haven't really defined rate yet. A rate is basically a ratio of two numbers with different units. So you're probably pretty familiar with this, like if you're driving a car, something like miles per gallon. Maybe your vehicle gets 25 miles per every 1 gallon of gas. A lot of times with money, you could say it's like dollars per pound, dollars per ounce. If you're buying meat, or if you're buying any produce, stuff like that at the grocery store. All right, so let's get into some examples. So number one, solve a proportion. I chose this one just because it looks a little bit tougher. You have an algebra expression on top. So we're going to cross multiply. 4 times 45, well, that's $1.80. And then go the other way. You got to almost think of it as distribution. So I got to do 9 times r and 9 times 3. So that's 9r plus 27. And now I just go into normal algebra. Subtract that 27 from both sides. That'd be what? 153. And then divide by 9, and I get r equals 9 goes into 15 once, 63, so that'd be 7. So r equals 17. And then you could check it out. If you wanted to plug it back in, you could plug 17 in for r, and you'd have 4/9 equals 17 plus 3, which is 20/45. And I can see that this is going to work out because this top is exactly 5 times larger. This top is 5 times larger. And I could also check cross products. I got 180 equals 180. So cross products are good. All right, next little section here. Find percents. There's something known as a percent proportion. Some people use the proportion, some people use the equation. So the percent proportion looks something like this. You have your part over your whole, and then you have the percent out of 100, because that's what percent means. Cent is Latin for 100, and per means out of 100. So that's basically what a percent is. If you're doing word problems, sometimes a little clue, this is kind of the is, and this is what it's out of. So you can kind of use these little keywords sometimes, not always, but sometimes that helps out. All right, so I'm going to set one up and do it this way. It says in Michigan the sales tax is 6%. If you buy a used car for $4,500, how much sales tax will you pay? Every state has a different sales tax. Michigan here is 6%. So we basically need to find, if I look at this, we need to find, what is 6% of $4,500? That's kind of the question that we're asking. So I could use this proportion. what is, well, I don't know the part. I don't know my part that's the tax. I do know the total of the car is 4,500. And then the percent is 6% over 100. That always goes there. And, you know, so these are the three things that could change depending on the problem. The 100 is always going to be there. But then I cross multiply. I get 100x equals, what's that? 24 plus 27,000. And then I'm going to divide both sides. Divide by 100. Divide by 100. And just double check my math here. I think it's going to be bigger than that. 27,000. That makes a little more sense. And then divide both sides by 100 and $270. This would be the tax. Well, then it says, what is the final cost? What is the final cost? And the final cost, I just have to add the tax back in. So 4,500 plus 270, 4770. Now, I don't usually use the percent proportion most of the time. I use the percent equation. So most of you would probably look at this problem and you would say, well, there's an easier way. You know, when you want to do what is 6% of 4,500, you just turn this into a decimal. You go 0.06 times 4,500. And that will also give me 270, and it's quite a bit faster. So you can always multiply the percent times the original price to get the final, or to get the part, I guess I should say, if we're putting this in terms of kind of like up above. This would be the part, and this would be the whole amount, or the total. Now, if you want to get the final cost, like if you just want to cut right to here, there's a neat little trick where basically you're just going to add a 1 in front of that 0.06. And if you do that, so let's say that I had the car for $4,500. Well, multiplying by 1 gives me the price of the car. So that kind of gives me the original amount. And then adding the tax in, that does it all in one fell swoop. So that'll give me my 4770 right away. So I do that 1.0 whatever a lot of times when I just want the final price out the door. All right, number 3, Milan High School, 225 students, or 35% of the population play a sport. How many students does our school have? So what we're missing here, we're missing the total. That's what we don't have. So if I want to use the equation, so here would be the equation model, I say, well, 35% of what is 225? So I'm like, all right, if I knew how much it was out of, I would go 0.35 times, problem is, I don't know the total schools, but I do know the part. The part is 225. So it ends up being a division problem. You divide both sides by 0.35. And let's just do that. 225 divided by 0.35 is, we have to round it roughly to 643, squiggly, put about 643 students. So those are a little bit tougher when they give you the piece. Again, if you wanted to use the proportion, I'm not going to solve it this way, but you could set it up. You know, the part, or actually the percent is 35. So those are two numbers that I know. On this one, I did not know the total. So my X was down here. And I knew 225 was the piece of the total. And then you could have cross-multiplied and solved it that way. So this is for the people who kind of prefer the percent proportion. I'm kind of an equation guy. It seems to go a little bit quicker. But you have to develop your own style. All right, converting rates. These can be a little bit challenging sometimes. And you do these a lot in science class, especially physics. So I want to get you really good at that this year. So it says a high school girl that's being recruited for softball is throwing 65 miles an hour, pretty fast. If the pitcher's mound is 43 feet from home plate, how long does it take the ball to cross home plate after leaving your hand? So that's our question here. How long does it take the ball to cross home plate? Well, I think the answer to this is going to be in seconds. All right, it's going to be something seconds, and probably less than a second, because I've watched softball, and the way they whip that thing in there, you don't really have a lot of time to decide if it's a ball or a strike. But notice that we have 1 unit in miles per hour, and then the next thing we have over here is feet, and then we know that we need to get to a unit of seconds, because we're not going to represent it as it takes so many hours to get to the plate. So here's kind of our goal, and this is our big picture goal. Our big picture is right now we have miles over hours, and we need to get over here to feet per second. All right, so that's kind of a long-term goal. I need to get from miles per hour to feet per second. Maybe I'll just kind of put that up here. Miles per hour, eventually to feet per second. All right, well, I'm going to show you kind of a classic way of how you handle these. And you basically just set up a bunch of ratios and you multiply them out. So we start with the ratio that we have. We have 65 miles per 1 hour. Well, what I want to start doing is I want to start putting conversions, and I want to try to get a unit on bottom and a unit on top to cancel. So for instance, let's go after the time part first. 1 hour, I want to get rid of hours. So what I'm going to do is I'm going to put hours on top, and I got to think of a conversion. Well, I know that 1 hour is 60 minutes. All right, so right now I've gotten rid of hours. I have hours on top, hours on bottom. Well, now I want to get rid of minutes. So I know that 1 minute is 60 seconds. So now I can get rid of minutes. So now I have miles per second on top, but I want to get feet. I want to get rid of miles and I want to get feet. So I have a mile on top. You know, right here is a mile on top. So I need to put the mile on the bottom. 1 mile. And then I have to think of a conversion of feet. And remember that this is something you ought to memorize here, there are 5280 feet equals 1 mile. So I'm going to put that on the chart here. And I'm going to put 5280 feet is 1 mile. So now I can finally cancel the miles to miles. Now I have 4 fractions that need to be multiplied together. So it's pretty easy. You just multiply all the top numbers. So I got to do 65 times 1 times 1 times 5280. So I'm going to use a calculator for that one. So 65 times 5280 is 343,200, and that's feet. And on the bottom, I have 60 times 60. The 2 ones don't really do anything. So that's 3,600 seconds. All right, well, let's divide that out. 343,200 divided by 3,600. It looks like this girl is throwing 95.3 repeating feet per second. So we've converted miles per hour into feet per second. But we're still not done. Although now we have something pretty good. We still got to use this 43. So think about this kind of conceptually. If she can throw at 95 feet in 1 second, she's going to throw at 43 feet in less than 1 second. So here's where we can use a final proportion. You know, remember, these are just ratios multiplied together over here on the left. But I'm going to actually do a proportion here. If she can throw 95.3 feet in 1 second, then she can throw it 43 feet in how many seconds? So now I have this one final cross-multiplying thing, feet per second over feet per second. And I can cross-multiply. Notice that I had to match my units up. When you do this equal or this proportion, if you have feet on top, seconds on the bottom, you got to keep it the same. So let's cross-multiply here. 95.3 x equals 43. So I cross-multiply there. And divide the 2 out. And you might have just realized intuitively that this was going to be a division problem. And that's okay too. So let's divide it out. 43 divided by 95.3. Let's put a bunch of them in. 0.45 seconds. Wow. So in less than a half of a second, an elite high school pitcher, you have less than half a second to decide whether that ball is going to be a ball or strike. Well, less than that, because you have to start swinging well before it goes across home plate. I want you to compare this reaction time to one of the problems in your homework where it's a baseball player throwing 85, but the pitching distance is a little bit different. It's 60.5 for high school baseball. So I want you to kind of compare reaction time there. All right, I think we got one more. This goes back to geometry, this indirect measurement, measuring how tall something is without actually having to measure it. You're wondering how tall the water tower in Milan is? I could not find this. I did a little bit of just quick research online, just quick Googling. I couldn't find it. So if anybody knows the real value of this or has the time to go out there and do this process we're about to do, I'm curious how tall it is. It says you're a 5 foot 8 inch tall and you measure your shadow to be 2 feet. If the tower's shadow measures 42 feet, how tall is the tower? So we kind of set up, a little picture here. Got a person. We got this big water tower. I think right now it says something like Milan 1954 for the state champion basketball team. And if you kind of do the shadows like we did in geometry, you can use similar triangles. To solve this. So if this person is 5 foot 8 inches tall, well, to make this into a decimal, 8 inches out of 12, 8 inches to 12 inches, well, that's 0.6 repeating feet. So I'm going to set this up, and I'm going to put the height over the shadow, and then the big height over the big shadow, and that's going to be our proportion. So little h is 5.6 repeating feet over, you measure your shadow to be 2 feet. So my shadow is a little less than half of me. So then we know the actual shadow of the tower, but we do not know the big H. We don't know the true height. So again, this is a proportion we can cross multiply. 2h equals, I got to do 42 times 5.6 repeating. 42 times 5.66 equals, that's 237 point, a whole bunch of nines. Let's just call it 238. And divide. Boom, boom. Looks like we're roughly at about 119 feet. Now again, that's not for real. So if somebody can dig that up and find it, I'd like to know the real height of the Milan water tower. All right, well, hopefully these examples help you out. They get you going on the homework. See you.